Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the Newton's three laws. To begin with, Newton 1, Newton's first law of motion says, an object will remain in a state of rest or motion in a straight line unless acted upon by a net force. So we see here an example is given that we have a diagram here, and all images are taken from this website www.fhsst.org, free high school science textbooks.org, and you can download it. It will be a useful resource for your studying. So looking at this diagram, discussing Newton's first law, we see here a person that's driving a car. Say the person is driving a car at 100 kilometers per hour. Then if he suddenly presses the brakes, what actually happens is that the car will slow down and stop, but the person in the car will continue moving at 100 kilometers per hour. So this object, the person in this car, will keep on moving at 100 kilometers per hour unless acted upon by a net force. And in this case, the net force will be the seat belt, which pushes him back and brings him to stop. So the object in the car will continue moving at 100 kilometers per hour unless another force makes it stop moving at 100 kilometers per hour. So that is continue traveling at constant velocity in a straight line. Similarly, if an object is at rest, an object is standing still, then in order for the object to move, there has to be a net force that is applied to the object, which makes the object move. So assume that there is no friction, then the moment you apply a force of 10 newtons, or whatever the case may be, this object will move to the right. And if there is friction, so if there's friction, for example, on this side with say 20 newtons, then what we will notice is this object will not move because the friction force is greater than the applied force. So if you apply a force of 10 newtons and friction is 20 newtons, then the object will not move. But however, if the applied force is greater than 20, say it's 30 newtons, then what we will notice is that the object will move because there will be a net force of 10 newtons to the right, which allows the object to continue to move to the right because there is a net force. So looking at it here, we can say that unless acted upon by a net force, the object at rest will move. So this block will stand still, but if there's a net force of 10 newtons pushing it to the right, then the object will move to the right. Now going further, we can look at friction. When it comes to friction, we get static friction and dynamic friction. Static friction will apply for an object that is at rest, and dynamic friction will apply when an object is already moving. Now I have a small applet here, and this applet is taken from PHET. You can go and visit them. They've got beautiful applets to download for free. And here, if you look at the diagram, the information that is given, we have a crate which the man will push shortly. And the object, the crate, has a mass of 100 kilograms, and we have a static friction of 0,5, and we have kinetic friction of 0,3. Now what we always notice is that the static friction is always greater than the dynamic friction. So in our case, we have an object of mass 100 kilograms, and there's a static friction of 0,5. Can we see what we can do with this when it comes to our sum? So looking at our diagram, we see that we have a coefficient of friction of 0,5. And looking at the diagram, we see that we've got the mass of 100 kilograms. So let's see if we can work out our frictional force. And then we have 100 kilograms. So what we will have to do is, if you take the weight, W is equals to mg. The mass of the object is 100 kilograms, and the gravity applied to the object is 9,8, because gravity is always 9,8. And here we work it out, we see that the gravitational force acting on the object is 980 newtons. So what this means is that here's our wooden block. We have a gravitational force of 980 newtons acting downwards, which means that we have a normal force of 9, or some say reaction force of 980 newtons acting upwards. So here we can say our normal force here will be 980, and 980 times 0.5 will be 980 times 0.5 gives us 490 newtons. So this means that our static friction, the frictional force of this crate, is 490 newtons. Now if you look at this diagram here, let us put it, I've put in some values earlier, so let us play and then we'll see what happens. So here we have a force of 450 newtons that's applied to the object. Here we have the blue, which is the gravitational force of 980 downwards, and here we have our normal force of 980 or upwards. You see that the F applied is 450 newtons, and that means the F of friction will also be equal but opposite of 450 newtons. But in our calculation, we came to the conclusion that our static friction, our maximum static friction, Fs max, our maximum static friction is 490 newtons. The moment we apply a force of more than 490 newtons, we see that the object will accelerate. Now let us look at it. There we have a force of 490 newtons, and now we will see that the force becomes 491. And the moment it becomes 491, we'll see that this object will accelerate. In this case, and then here you see that it moves to 491, and then the object starts accelerating. Now, coming back to our diagram, let's work out our static friction, kinetic friction. We see that our coefficient of kinetic friction is 0.3, and our normal force is 980. And then if we say 980 times 0.3, we see 980 times 0.3, we get 294. So as we see here that our dynamic friction now is 294 newtons, which is less than the 490 newtons. So if we go back to our applet, and as we saw that because we had 491, this object move forward. But if we change it to 294, we see that the object is actually continuing moving. So you have to apply a force which is less than that to overcome static friction. So you have to apply a force of 490 to get the object to start moving to 491, and then we see it accelerates. And then while it is moving, if you apply a force of 294 newtons, we see that the object moves with constant velocity. And then I just went further in this applet that if you apply a zero force, if you leave the box, now what happens to the box? So it is moving at a constant velocity. And then if you leave it, we see that only friction is applied onto the object, and the object comes to stop. So we look at it again as it's applying at 490 newtons. The moment it becomes 491, it accelerates. At 294, it moves at constant velocity, and friction brings it to stop. So that's interesting. And then going further, I've said that if you're applying a force of 900 newtons, which is far greater than the frictional force of 490, that means you're applying a force of 900 newtons, then the object's static friction was only 490. So while it is moving now, the static friction is no more, it becomes dynamic friction, which is 294. Then because the applied force of 900 is far greater than 294, we see that this object will accelerate. So I will stop there today, and I've discussed friction, and we see that we have a difference between static friction and dynamic friction. When an object is standing still, then we have to overcome the static friction. In our case, it was 490. The moment we went greater than 490, the object starts accelerating. Then we see that we have dynamic friction of 294, so that when we have a force of 294 applied on the object and the dynamic friction is 294, then we see that this object moves with constant velocity. However, if you apply a force which is far greater than dynamic friction, then the object will accelerate to the right. So we will stop there and we will continue with Newton's laws in our next session. Thank you very much for watching.